I'm Vinod Vijay Kumar, a director of CAD, Chennai Academy of Architecture and Design, Chennai. I'm extremely delighted to welcome our guest speaker for today, Mr. Francisco Godoy, co-founder of Studio Alinea, Chile, South America. All of us are delighted to have our esteemed chairman, Professor Dr. V.R. Rajendran, amongst us today. I welcome all of the CAD students, along with their family members, faculty members, and friends of CAD from the practice fraternity who have gathered to enjoy this evening through this wonderful lecture on sustainable architecture, working with nature. A special thanks to architect Shiva Shankari to bring our speaker on board for the lecture. Our chairman, Professor Dr. V.R. Rajendran, has held the highest positions in academics as Vice Chancellor of University, appointed by the University Grants Commission, Government of India. He is a government-nominated member in many universities and councils in India, such as the Pharmacy Council of India, Indira Gandhi National Open University, and Periyar University. I request our chairman to welcome the gathering, please.
Thank you. Good morning to Professor Francisco and good evening to the director, faculty members, parents, special invitees, and my dear students. It gives me a great pleasure in welcoming you all to this special lecture series of CAD. CAD, Chennai Academy of Architecture and Design, is specially meant for offering the B.Arch architecture course and is striving to be the best in India now. Even during this pandemic period, CAD is continuously conducting the online education every day to the students to prove that we are intact and our education is not broken in the midway. I thank my dear students for extending their fullest cooperation in attending the online classes every day without fail. It gives a great pleasure to me to see that our students are courageous, confident, and united to face any situation in the world with great success. And today's this lecture series from Professor Francisco is going to be a great informative for us. He is going to speak on sustainable architecture. You know, in this after this corona, it is expected that there is going to be a great shift in and redefining and reshaping of infrastructure in industries and human life sectors. Architects are going to play a major role now, henceforth, for redefining the same to suit the needs of the people according to the nature. I am sure this lecture will give us a great input in that. I wish you all best of luck and wish you all to stay safe, stay healthy. Good luck. Thank you very much.
Thank you very much, sir. Thank you for the very confident words. Since we have viewers from both India and abroad, and a lot of new viewers who are interested to view this lecture itself, I would like to give a quick introduction to our institution and the event. CAD is affiliated to Anna University, one of the oldest technical universities in India, and approved by the Council of Architecture India. It is one of the very few standalone architecture institutions purpose-built for a studio-based design course such as architecture. Holding the office of the Vice Chancellor of a university for 2 terms, our chairman has a penchant for quality in academics. My specialization particularly being in planning and urban design from National University of Singapore with international practice for several years based in Singapore. CAD has built a tradition of constantly bridging academia and profession through the regular lectures that we used to host at our premises ever since its inception. Coming from the practice myself, I always thought it is important to give the students a perspective of academics from the practice point of view. And therefore, we built this platform called the CAD Lecture Series, which is an open forum for architects and professionals from allied fields to present their works and philosophies to our students and the general public. This platform has helped our students build their focused interest
Meeting चले से सापड़िया.
in key disciplines related to architecture and set their future career direction. I wish to give a quick introduction to the speaker. Francisco Godoy is an architect with earmark in sustainable and environmental design from the Architectural Association London, UK. He has worked for more than 12 years as an independent architect and founding partner of Studio Alinea, Chile. Studio Alinea specializes predominantly in the disciplines for architecture, sustainability, and landscape. His practice and academic exposure during the past years has been focusing in architecture and climatic design strategies to adapt buildings into its surroundings. Sustainability, as all of us know, is the most sought after, but it also becoming the most vulnerable term to be mentioned in any forum. But the way Mr. Francisco Godoy has administered sustainability in his projects will be equally enjoyable by all. With this introduction, may I request Mr. Dushyant to connect architect Francisco for the lecture, please.
Hello, everyone. I wanted to first of all thanks the Academy of Architecture and Design of Chennai for the invitation. I hope you all like the presentation I have prepared for you, and hopefully I can leave a little feeling in you on how important nature is, and especially for architects to work with and consider it in your designs. I will start sharing. Yes, if someone can tell me if you are seeing the presentation.
Not yet.
And now?
Yeah.
Yes? Yeah?
Yes. Yeah.
Okay. So first of all, I wanted to start with a little bit of my experience and how I started this process as an architect. I'm an architect from the Universidad Finisterra. I graduated myself in 2008. I After graduation, I started working for Mapa Architecture, which was an office focus in housing. Then I founded Studio Alinea in 2009 with two of my best friends. In parallel to that, I founded also an ONG, which was called Tu Árbol, or Your Tree in English. We were focusing the development of green areas in low-income communities in Santiago. Then in 2013, I won a scholarship to go to London and study a degree in sustainable environmental design at the Architectural Association, where I did my thesis on ecotourism in Chile, redefining sustainable design for hotel buildings. Then I went back to Chile in 2015 and relaunched Studio Alinea as an architecture office, of course, but more focused on sustainability and landscape. And since 2015, I am also a professor at Finisterra University and some courses at San Sebastián University of Sustainability and Vernacular Architecture. So the structure of this presentation will be divided in three main sections. First, the environmental crisis. Second one, the academic approach, what I try to encourage in my students, that is the vernacular architecture, and trying to absorb information from those examples. And the third part will be my professional experiences so far with Studio Alinea and my office architecture. So it is well known for all of us that we are facing an important environmental crisis. We can see that every year we can see the increase in fires in agricultural sites, but also in places protected by the government, like national parks or even native forests. We have problems with water scarcity, and small towns or zones of the world that are getting dry every year, more deeper and deeper. Heat waves all around the world with record temperatures and dead people because of extreme heat. We have problems with glacier melting. I was reading the other day that especially the South Pole is melting on a rhythm that if it continues like this, probably the sea level will increase in more than 50 meters. So most of the places we know nowadays are going to be covered with water. We also have problems with floods, rain and snow in unprecedented zones that give us these alluviums and floods everywhere in cities. Probably all of this is happening because of the registered increase in the temperatures all over the world. I don't know if it's 2 or 1 degrees during the last 20 years, but it is certain that nature is trying to say something to us, and that our activities are having an impact in the world that is going beyond normal. For example, during 2016, the global tree cover loss was 21% higher than in the last 20 years. In 2017, here in Chile, we lost more than 450,000 hectares of forest. This was more than in the last 10 years. Also in Chile, we have this lagoon very near the capital of Santiago that it's called Laguna Aguleo, which is completely drying out since 2010. This lagoon was used by people to go on holidays, weekends, and no one is going there anymore. These were, for example, the global effects of the heat waves during 2018. We have more than 70 people dead in Canada, more than 80 people dead died in Japan, record temperatures in Africa above the 50 degrees, and it really doesn't get better. I don't have too much to say about this image, but you can compare from 1931, a photo of the Chilean south part, and 2016, and how the glaciers are melting every day. So I just wanted to imagine how many birds, animals, or even plants had to move and found better places to live. How many of us will have to move in the future because the environment that we are creating is no longer suitable for us? In parallel to this, we are in the middle of a political crisis. Every year, everywhere around the world, people is asking for changes in the economic system and trying to foster real changes for the good of the planet. Clearly, there are some that understood the situation, but we still have people in power that think that global warming is an invention of the Chinese government. So this anomaly in temperature that we were talking about before has been confirmed by different entities and offices all around the globe. For the ones of you that are not still related with this subject, the greenhouse effect is a process that occurs when gases in the Earth's atmosphere get trapped and trap the heat produced by the sun that hits the Earth. This actually makes the Earth a very comfortable place to live for the humans, right? But the problem is that these gases that trap the heat have never been so high, especially the CO2, that had never gone beyond 300 parts per million in the history of this planet, and nowadays is reaching almost 400. This graph is part of the movie An Inconvenient Truth that I should recommend to all you to see. It was directed by Al Gore in 2006, and he was a former USA president candidate, and explained very well and in detail this process of global warming that we are living and how we should face it. So the CO2 comes from most of the activities we do in our daily routines, especially the energy we use every day. Probably all the energy we consume, all the activities we do, all that energy comes from oil, coal, and gas. Those are non-renewable energy resources, and they produce also high CO2 emissions. So from the total energy we use in the planet, which is this pie chart, the 33% is used for transportation, the 26% is used by industries, and the 41% is used by us in the places we live and use every day. From that 41%, the 46% is used for heating and cooling, especially our houses or offices. So there is a big challenge for architects today. How are we designing the spaces we are living in? How could we reduce the energy consumption of these spaces of these buildings and the CO2 emissions related to that? Unfortunately, we still give credits to this kind of architecture. I know this is in Chennai and was designed by Zaha Hadid Architects. I know it's maybe an important pole of development for the place. But wait, we are in latitude 12. So this means we are very near the equator, where the sun hits very hard, probably with 12 hours average of sunlight every day, some time of the year very humid or hot. So these kind of buildings, like completely glass facades, were designed originally for Germany, Switzerland, France, latitudes over 40, way far from the equator. And the bigger problem is that probably this building has a very high environmental certificate issued by LEED. Maybe it's gold or platinum, I'm not sure. What I'm trying, well, as you can see, again, this building is, as you see it and you understand that it has a high dependency on air conditioning. Its energy consumption should be very high. It has no sun protection, no transitional spaces from the hot outside to the inside. So probably if you don't have a continuous air condition working and spending and emitting CO2, this building will not be able to work. What I'm trying to say it is that if you go not very far from here, from Chennai, you will find this building or this typology, the Lana House at Thailand, at latitude 13, almost the same as in Chennai. I'm not saying we should go back to this, but I'm sure we can learn a lot from this to adapt the buildings into the climate and the local conditions, reducing the costs in cooling and offering the occupants a way more comfortable place to stay. From this architecture, you can rapidly see architectural strategies. Ventilated floor and roof, a large roof for rain and sun protection, very lightweight construction, transitional space. You can see a terrace, then a veranda, then the indoor living space. This is a building completely free running. They don't need any kind of energy to live in. So again, well, we can look a lot of time and spend a lot of time looking at this. But to make my point, I think this quote is very interesting from Le Corbusier, 1957. The tradition is the unbroken chain of all the innovations and then the surest indicator of the projection to the future. This means we should always look back before looking forward. This opens the second part of the lecture, which is my academic approach and my interest in vernacular architecture, which is the kind of architecture without architects. It is the purest architectural response to the needs of a person or a society. In addition, these methods and strategies that you can get from these architectural typologies are tested through a process of trial and error and directed by the adaptation to the climate, the availability of materials, the function and the traditions and sociological needs of a given culture. And we have examples all around the world, probably in India as well. We have this amazing construction in Norway at latitude 59, very near the pole, very compact, insulated, with small windows, everything to keep the heat inside. Then the igloo, an even more extreme example at latitude 75, where with ice bricks, the people were building these amazing spaces. As you can see in the section, the stratification improves the temperature in the indoor space, just using thermodynamics. The cold is going down always. That's why they were using this part of the igloo inside to stay and to sleep, always protected by the strong wind, completely aerodynamic. Another example is the Mayan house in Mexico, completely open at latitude 20, very similar to Chennai, fully ventilated with high thermal capacity materials in order to absorb the temperature during the day and able to release it when outdoor temperature goes down. Amazing wind catchers in Dubai also work with thermodynamics. The cold wind goes down this chimney, cools even more, passing through an underground tunnel, then go through a water fountain and gets into the habitable spaces of the house, offering a very better conditions for the inhabitants of the house. These are all strategies, very simple, using physics and of course reducing until zero the energy consumption of the building. To tell you a little bit about my country, in Chile we have more than 22 different climates, ranging from the driest desert of the world to the Antarctica in the South Pole. I wanted you to remember that the north for us is the orientation facing the equator, and the south is the other side. It's not like in India. This is due, the different climates that we have in Chile is due to three main factors. The first one is the longitude of the country. We go from latitude 18 till latitude 53 in the south, more than 6,000 kilometers of coastlines. The second factor is the Humboldt Oceanic Current. That is an oceanic current that brings very cold water from the deep sea to the upper part of the sea, drying the atmosphere and in that way producing this dry ambience in the zone of Atacama. And also the geography of the country. We have the Andes Mountains on one side, and these produce several valleys in the middle between the Andes Mountains and the coastal mountains. We also have different kind of vernacular typologies, ranging from the extreme north with the house of Atacameños, in the Central Valley, the Chilean traditional house, and the ruca, which is the typology that our Aborigines were using before the arrival of the Spaniard. And then in the extreme south, we have the palafitos, which is a house placed in the middle between the land and the sea on stilts over the water. So I would like to go a little bit deeper in one of the Chilean traditional houses. All these analyses are part of the investigations we do in my academic courses. The Chilean traditional house is at latitude 33 with a climate which is hot during the summer but very cold during the winter. This house is an adaptation from the Conquer typology, the Aragonian house that comes from Spain. This house from Spain was a three-story building with a small patio in the middle, and probably in Chile, because of the available materials and the earthquakes, it was built in one story with one floor, but more expanded, completely looking inwards as a way of protecting the family from the Aboriginal attacks. It was divided by two courtyards, one social and one private, with corridors and eaves that configures transitional spaces all around the house. These eaves were designed with solar geometry, allowing the solar radiation inside the spaces during the winter and blocking it during the summer. The material, which is adobe, a mix of straw and mud, offers a high thermal capacity material that again traps the heat during the day and releases it during the coldest hours of the night. These two courtyards, of course, were spaces of social delight, but also, if you see the floor of them, they were made of stone. They were also trapping the heat that was receiving during the day, and during the night, with the cold winds going down the center of the courtyard, as you can see in the schemes in the bottom of the diagram. This heat moves from the center to the interior spaces and corridors of the house. The trees that you can see in these courtyards were also a decision. The palm tree acts as an umbrella, blocking the solar radiation into the courtyard during the summer when the sun is very high, but allowing the sun inside the courtyard while the winter when the sun is lower in the horizon. So as a conclusion to this part, I would like to read this quotation from Amos Rappaport from his book called House Form of 1969, that I think it resumes somehow what architecture, what vernacular architecture is, and the importance that we have to take into consideration these strategies and apply this in our designs. So these builders and artisans have learned to solve their problems collaborating with nature, considering that each failure would mean having to face the forces of nature in first person, which is not the case of an architect designing for someone else. His buildings have long been adapted and designed as natural refuges to protect and safeguard life, without matter what that means. So this is how we open the third and final part of the presentation, my professional experiences with my office, Estudio Alinea. The first one I wanted to show is this in Chañaral. This is the second region, extreme north of my country, latitude 23, a very desertic climate, very dry, but hot during the whole year. So during March of 2015, they had unprecedented rains during the summer that produced a huge alluvium inside the city, with more than 30 dead people and 8,000 people damnified, everything completely flooded. So this was more left the before and after, and you can see in the right the water stain that goes through the city, destroying almost everything on its way. So we were invited to this huge challenge. We had 120 days as part of a interdisciplinary team of professionals to build a master plan for the city, and also organize and rank the investments of the city for the next 10 years. We build this structure based on analysis, diagnose, and proposal, specifically on these four main subjects that were fundamental for us. Protect the city from its geographical risks, the urban growth and the regulations of the city, how the city was growing and how it was moving. Also the mobility, understand how the people was going from one side to another, and of course the public spaces and green areas, to understand if the people was using or not the city. Our main objective was to create the first city in Chile that organizes according to climate, geographical risks, and sustainable mobility in public spaces, and public spaces centered in people. So the final outcome of this, of course, in addition to the analysis and all that, was the master plan and 10 activation projects for the city. So here we will see 4 main plans of diagnose, which were the ones that lead us to our final proposal. The first one is for you to understand a little bit about the city. Chañaral is a coastal city. Here is the Pacific Ocean. Then is crossed by the Rio El Salado, which is this dark stain of water. Chañaral was exposed to 2 tsunamis about 30 to 40 years ago. And in addition to that, it is surrounded by big mountains made out of sand. So they have quite fundamental risks of mass removal. So as you can see, the city was surrounded by geographical risks, and all of its important infrastructure, which is highlighted in yellow, was exposed to the risks. The day of the alluvium, the firemen, the police were all in the city center right here, and they were not able to help the rest of the city. So the second one of the plans is the urban growth, a plan that crossed with the urban regulations, allow us to notice that the city was growing into its boundaries, and almost all of them were related with risks. The city was growing a lot here along the Salado River. It was growing here up the hills, where they have these important risks of mass removal, and also up the broken mountains that surrounded the city, and even into the beach. So the urban regulations were in some way promoting this urban growth. We proposed to densificate the city, stop the urban sprawling, and the densification, we proposed it along the coast, which was more safe for the people. They're here in this side, as you can see in the previous image, they didn't have the risk of tsunamis. And to connect this city with this another small town, which was called Barquito. This third plan shows the mobility, which was a complete chaos inside the city. We organized 3 dynamics according to fluxes and the different velocities inside the city. We had a good network of bicycle paths and also reduced the use of cars in the city center. The public spaces were also a big problem. None of them consider important infrastructure in relation to the climate. There was no shading in any of these public spaces. Most of them were residual spaces of the city and were all trapped by drug dealers and gangs. So also the location of these public spaces was a problem. Most of them, or the configured ones, were in the perimeter of the city and were not part of the daily circulation of the people. So as you can see in the final outcome, we propose a several line of decantation pools to reduce the risk of alluviums, a mitigation park in front of the beach with infrastructure to reduce the speed of possible tsunamis, and important networks of roads and paths for different uses, promoting the mobility inside the city, the use of bicycles, and of course, this is a small town, no more than 30,000 people, so it was easy to move from one place to another. And also more than 30 projects that are the red dots that were fundamental for the economic growth of the city in its future. So we developed 10 of these red dots for construction. This was a market for the city center, the new municipality, different ways and paths inside the city that were more focused on people than in cars, We also renovate some existing parks inside the city and promote the tourism as one of the main subjects and issues of the city for its economic growth. So I will pass now to a completely different scale. This is a house refurbishment in Santiago at latitude 33. The climate here is very hot during the summer, but very cold during the winter. And what I like about this project is that originally, as you can see in the plan at your left, this house was oriented north. The north is looking down. That's our best orientation. And all the south side of the house was dark with no natural light, very humid, and you don't have the possibility of going to the main garden, which is this one. So it was completely closed, and you could only go through the main bedroom, which is this one. So we managed to, with small movements in the first floor, we moved 44 square meters in the first floor from the 130. We convinced the client about opening a small patio here in the center and design a family room in this place in order to open the south garden of the house and have an open circulation from one side to another. This is the section we propose, and using solar angles and white walls inside the patio, we managed to give natural light and ventilation to all the south side of the house. If you see this image, look how the small patio works. It completely changed the structure and the atmosphere of the house inside. This is also the proposal for the second floor. It was a large volume, very clean, but also very conventional inside, so I will not wait too much time on that. So we also designed a ventilated wall for all the second floor that we add to the house. The exterior panels are made of back steel to improve the ventilation inside the walls. As you can see how it looks, the patio, the main facade at the east, and the interiors and the terrace of the second floor. So this next scheme, it is a house we hope to start building after the pandemic of the coronavirus finishes. It's in Casablanca, latitude 32, very similar to the climate of the previous house, but more near the ocean. It's for a family that lives in the USA, but comes sometimes of the year. Sometimes comes just the mother, sometimes the whole family with 4 kids and full of people. So it was quite challenging to create a house that has the ability to adjust for the amount of people that was coming. The site was very interesting. It was a small slope to the east, full of very high trees. And as you can see in this plan, the sun was not in direction to the same space, to the valley, but we have the prevailing wind. We have also a main house with a pool and a tennis court that we have in some way to connect with this new house that will be positioned in this place. So we run first some solar studies. Here we have the winter solstice, the equinox, and the summer solstice at 3 different times of the day. With that, we were looking for the best position for the house. The airflow, we conducted the simulations with Winner in Ecotech, was quite regular and well distributed in this space. So we have good nature conditions. We were understanding how the natural conditions of the site were in order to adjust our design. So we were ready to start building. From this main volume, we divided into 3 parts. We had this horizontal circulation. We had the natural ventilation, of course, and the solar radiation that was very important for us. But also we wanted to have the landscape inside the house. So as you can see in the final plan, we did 2 main entrances, one from the parking lot, which was in this place, and another one that was coming from the main house. And we placed a big patio in the middle of the house, in the center, to improve, of course, natural lighting and ventilation across the plan of the house. And we distribute the program in these 4 main bedrooms that were fully equipped, that could be used for 1 family or 4 families at the same time. So these are the exterior views of the projects. It was also designed with ventilated walls, which is an amazing strategy to reduce energy consumption in climates like this, which are cold in winter and quite hot in summer, as I was saying. This is a view of the interior and the patio, and you can see how the space is going very fluently from one place to another. Here we have another images and perspective of the house. We also always test the interiors. This is a simulation for winter solstice at 12:30. They wanted a very lighted house, and probably they will have it, as you can see. So this is the first project I will show you in Puerto Varas. This is south of Chile at latitude 41. The climate here is quite cold during the whole year, very rainy, and they have no more than 2 months with a hot period, but not very intense. This project is for a restaurant. It was in the middle of this plot with this amazing nature, with these woods and forest, and also a river that was going through the plot. It was also in the Riviera of a lake, the Lake Llanquihue, which is one of the biggest lakes here in Chile. And what was interesting about the plot was, of course, its relation with the lake, but also the orientation that it has. Since it was completely oriented to the north, which is our good orientation, the facade facing the equator. And it was, of course, in the middle of this forest, so it was very challenging to illuminate the interior of the building. In this case, the nature was talking us more from the landscape, so we recognize 4 different landscapes inside the plot. As you can see here, we had this first space that it was more like a forest. Then there was the second part, which is related to the river and with a specific vegetation in this place. Then we have the Lake Riviera with also a very specific kind of vegetation, and then the beach and the lake. And so our first proposal was to create an experience on the people who visit the restaurant. So the first line was this long path that was crossing the 4 different landscapes of the plot. And then a second system of paths that was connecting the other programs of the project, like a small house, the orchard and winter garden, the beach. and of course the restaurant, which was the main attraction of the site. With the program, we wanted to create an interior-exterior space, a place where you have all the thermal comfort of the indoors, but with the continuous presence of the outside and the surrounding. So we proposed the kitchen on one side, as you can see here, the kitchen and the services on one side, and the bar at the other side, leaving the main space in the middle, in a direct contact with the nature and the outdoor landscape. As you can see, we use transitional spaces with exterior corridors to somehow to create a graduation of temperatures from the outside to the inside, insulated night shutters to keep the interior warm during the night. You can see that the interior is very comfortable with good natural lighting. I will not show the simulations we did because it will be very boring, but also is very good ventilated. This all-wall is a sliding window that moves from one side to the other. You can see also how the project funds with the landscape and the nature around. And I have heard that also the food is very nice. So this is another house project in the south, same climate in Puerto Varas, latitude 41. Very cold, as I told you before, rainy all year long. The plot was very big in this case, almost 5 hectares. So the north was looking up, and the wind was coming from the north during times of bad weather, and from southeast with good weather. So we first conducted some wind studies. Because when you have wind coming from the north, which is your open orientation because you want the sun to come in, when it rains, the rains, because of the speed of the wind, lays down and hit your north orientation, producing a lot of problems like water leaking inside or problems with the windows and all that. So we proposed to the client a small forest in this part of the plot in order to reduce the wind speed and in that way protect the house also from the cold winds. This was our first proposal. Then, in order to understand in which part of the site we should place the house, we ran the simulations of solar, of sun shading studies to understand where we could ensure solar radiation for the house during the whole year, considering the new trees we planted in this site. So we found this place that was completely open to solar radiation, and it was just shaded a little bit in winter at 9 a.m. and at 4 o'clock, but during the rest of the year, it was completely open to sun. So the main strategies here were the capacity, of course, good thermal envelope, solar control for summer, the interior distributions in order to put all the services in the south side, the circulations in the middle, and the habitable spaces on the north side related with the sun, natural ventilation and lighting, of course, and the use of intermediate spaces to have a sequence of spaces that rank from cold to warm, like a thermal graduation. So this is the scheme for the first floor. You get inside here, you have a wind draft lobby, which is an architectural element very common in the vernacular architecture of this region. Then if you go in, you here have the living room and dining room, the kitchen, and this was a conservatory. also to trap energy and heat from that space and transfer it into the interior in the coldest day. While in the second floor, you have all the bedrooms, specifically the family spaces or private spaces and a family room, all of them completely oriented to the north. Well, this is how it looks after building from the east side. The interior and stair, the building, the materials are most of them recycled wood. This family, it's a family of farmers. They produce sheep milk, so they have the sheep all over the plot, which is quite interesting. The north facade of the building was designed with a window-to-floor ratio of 45%, which is a fundamental analysis and calculations that you have to do in order to maintain the thermal balance. Also, the interiors that were designed very specific. You can see here we put a sliding panel to connect the living room with the kitchen, something that was a requirement of the clients. And also at the end you have simulations of solar shading for summer and winter, and you can see how the house is completely exposed during the winter, completely exposed to sun, but during the summer completely shaded, and the sun is keeping outside. So this is how it looks like from the other side of the river. So one of the last projects I'm going to show you is another housing project in Puerto Varas, same location, latitude and climate. Although the plot was quite different, it was kind of divided into two parts. An upper part more exposed, which is this one, more exposed to sun, and a lower part that was more humid and dark, but more related, of course, with the lake, which was in this side. The sun was in the front, so no problems for that, but the wind, same as we see before in the previous case, was coming from the north with bad weather. But since we have this interesting forest in front, there was not big deal. So we have that solved in some way. So we first did some solar studies again to confirm somehow that the upper level was the best position for building the house. The program is for a family with 3 kids. So we divided the building into 3 different parts: the rooms, the communal areas, and the service. You come into the house in this part, and if you go to the right, you have all the rooms, the main rooms, the main bedroom, and the kids' bedrooms, and a family room here. But if you go left, you have all the communal areas with the kitchen, living room, and dining room connected with the services area. So as you can see, we use a continuous eave. We design with solar geometry, allowing the solar radiation inside during most of the year. As I told you before, they just have this hot period during January and February. But we also designed this eave in order to keep the sun outside during those months. You can see a continuous terrace along the house in the outside part, protecting the interior and regulating the temperature from inside to the outside. You can see the inside, we're in direct relation with the nature, with the outside, looking always into this amazing landscape that we have. Some solar simulations we did previously. For example, in the upper part, you have the main bedroom. This square here is the bed. And this was for June, so winter solstice at 12 p.m. And then we managed to took this image during the winter solstice after the building, just to prove and test the results of our simulation. So last but not least, I wanted to show you what we are actually doing right now. This is like kind of work in progress, but it's a 3-story building in Santiago, latitude 33, climate, hot summer, cold winter. This is a more commercial scheme, more conventional, of course. On the first floor, we have the entrance to 4 different houses. You enter from here, and you go up to the communal areas in here. Although it is a commercial scheme, it's also interesting for us in our office because we think it's a very good way to densify the city. We have some strategies to adapt the building into the climate. We have in the south orientation most of the bathrooms and cold areas of the place of the building, while at all the living areas and the main spaces are north oriented. So this is the distribution. You can see here, we go in, we go up, we appear here. Then you have all the communal areas, kitchen, dining room, and living room with a terrace. And then in the 3rd floor, you have all the bedrooms for the house. So this is how it is looking now, and probably we'll start construction during next month. So, well, that's it. Thank you.
All right, thank you, Professor, for your very insightful presentation. I think I really like how you are able to bring into the perspective of an academic standpoint and very nicely transitioned into the practical application of everything that you have shown us today. And really appreciate how before every project you posed a question and a particular question that you had to answer, and sort of got our minds thinking and ignited some possible solutions that can come out from this presentation. I think our students would really appreciate the amount of calculations, the technological advancement that has come through, the simulations, and then the amount of study that comes before making a particular sustainable building. And we have received so many questions from our students, which I am hoping you would be able to answer through the session. The first question that we have is many believe that vernacular architecture may be more sustainable and climatically responsive, but they may not be adaptable to meet the new lifestyle of the citizens. Also, certain vernacular practices may not be economically possible. One of the examples they have given us is a local construction, a local type of housing known as the Chettinad house, has about 600 mm thick walls to maintain a certain thermal mass. But if you were to provide such thick walls in the urban cities with such high square footage rate, it may not always be possible. So how do you address that?
Yes, I think, and I said it in the presentation, I think that vernacular architecture should be something that we always look to. We should try to absorb information from that, to understand the knowledge and try to adapt it to the actual conditions. That's why I was saying that we should not go back to that kind of architecture, but we should understand it and try to use it as much as possible. I know that are some things that are very complicated to do nowadays, but I'm sure that students and architects have the intelligence to apply this knowledge and use it in the projects nowadays. I see a lot of, and I like to be very critic with contemporary architecture. So I think that we can always do a little bit better. And when we see all these glass facade buildings, I get very confused because probably it looks very nice, but I'm sure that the building will have a lot of problems. It will cost a lot to maintain. Probably you will have some problems with the people inside, and they will feel probably more stressed, and a lot of things that come with another subject that was not part of this presentation, but that is the biophilic architecture and how people like we humans are used to have direct relation with nature, and since we are losing that connection, we are stressing a lot more in our works and current daily activities.
Fantastic. Actually, since now we're talking about the glazing technology, another student has asked us that many glazing technologies these days suggest that they have high VLT or visual light transmittance and reduced solar transmittance overall. Hence, can we say that we can still follow an international style of architecture even in a climatic condition like India?
Well, I think technology in glazing has been going very far. It is very well advanced, and I think that there are some products that are very interesting. I'm sure that it could exist. I think a glazing that reduces completely the solar transmittance inside the building, but the main problem is not just the glass. The main problem is that the U value of the glass is way lower than the U value of a wall. So when you have the comparison between those two elements, you are going to be losing a lot of heat through the glass, or you will be gaining a lot of sun through the glass. So you have to do this balance, thermal balance, between how much do you want the sun to get in and how much heat do you want to lose. But if you just put glass, you will probably lose a lot of heat that could be useful for you. And of course, in climates very hot, like in India, if you just put this glazing that completely reduces the solar transmittance, you could have another problems inside, like problems with too much light inside the space for the people, or another problems that we could address or look through or go through much deeper in another time.
Okay, so great. We have another question here. I think the students are a little bit more conscious about the economic point of view. The question is, was the capital cost higher when constructing a sustainable building? And if so, when did your clients break even?
Yes, well, that's a very complicated situation. That's why I put the last scheme about this townhouse that we are building, that it's a more commercial scheme. In that case specifically, we didn't have the opportunity to convince the client in order to take more decisions related with environmental strategies, because it was a more commercial project. Okay, let's say it was just like real estate. We had to be very efficient with the solution, with the square meters we were selling and all that. So that's why I wanted to put that at last, because in architecture you will always have to deal with that. You want to do the project, and you have to take the most decisions you could in order to reduce the impact of the building, reduce the energy consumption, choose the materials possible to create a better building. But of course, that sometimes a building which is more related with sustainability could be more expensive because you could spend more money in glazing, or you could put some environmental features that could improve the house in some way. But if you look again into the vernacular architecture, and you take those knowledge and you apply them into your house, they are not things that are more expensive. They are just things that change your architecture in a way that it will be just better and more comfortable for the people that is going to live inside your buildings. For example, in the houses I show you, we didn't spend more money specifically in the house or in the walls from what was other alternatives. But I think it was first, the most important thing is how you put the building inside a plot, how you arrange the spaces in direct relation with the sun, the wind, and all that, and then think very deep in the solutions you are proposing for the walls, and how the spaces are connecting inside, and how you could organize them together.
You've spoken about the different type of techniques designing for sustainable needs. Has there been any a parameter that you felt that was different when you're dealing with a commercial building and different when you're working with a residential building?
Probably not, because I am always focused on this kind of architecture, and I'm always looking into techniques or into, for example, the composition of the walls. I try to offer always something that it's good U values, for example, for the climate I'm working, or good materials with high thermal capacity. For example, for the central zone of Chile, which is quite interesting, and it is quite helpful for the houses. But it's not that I am using different strategies. Is that the plan or the architecture becomes a little bit more boring for me, let's say, because we don't have the possibility of moving a lot. I'm not sure if I answer your question correctly, but I think in both cases we are looking for the best solutions, but in one case we don't have the same possibilities and options to work with.
Right. Right. Actually, there's one question that I've had multiple students come with. So I'm just going to have like a general overall way of what they wanted to ask. There is a common perception in India, at least, that high-rise buildings are not sustainable. And most of your buildings actually are having large area, they have large area. So do you think that high-rise buildings can be made sustainable using the practices and techniques that you have had?
Yes, of course. I'm completely sure about that. I didn't add into this presentation, but of course, if you in a high-rise building, when you combine opaque elements with windows, you can get a really environmentally friendly building, let's say. I think that densification is also a very good thing for cities. We were talking in the master plan of Chañaral that I show you, that densification is very good for the city because you spend less money and energy in moving around the city. You walk more. In that way, you lose weight every day. You are healthier because you use your bicycle. You don't have to take your car every time to move around the city. So I think high-rise buildings, of course, they have some environmental issues that they, of course, are very useful. But I think that the problem that that most of sustainable architects we have with it, with these kind of buildings, is that most of them are glazed. And this is most of the times requirements that the owners of the buildings or the clients give to the architects because they wanted a building to look in a particular way that shows somehow power or a contemporary language. But the thing is that I'm sure that you, and I have some examples of interesting high-rise buildings that have very interesting facades, and they have movable systems in their facades. They change the situations of each facade in relation to the orientations in order to respond to the nature in different ways. So you cannot create a building that looks to the north the same way that looks to the south. In one orientation you have the sun, and in the other one you don't have it. So you have to take that into consideration and deal with it.
Okay, fantastic. I think for a concluding question, I think this is quite interesting.
Yeah.
How important do you think sustainability will be taken by citizens during the course of the pandemic, where we have restriction of movement of both people and goods? And in an urban context, where do we give that extent of sustainability? Is it every household within a neighborhood level, or is it going to be much larger than that?
Sorry, can you repeat the last part? I lost a little bit there.
Yeah, sure. They wanted to know, where does the urban context, in the urban context, where does sustainability lie? Within a certain household, a neighborhood, or is the extent going to be much larger than that?
Yeah. Well, I think that of course nowadays all our feelings and all our worries are with the pandemic. I think that all the world is looking at this main problem and how we could solve it. But I'm sure I'm sure that after this and after we pass through this process, the environmental crisis will be again on top of the discussion. I really think that sustainability should be in every step of our daily life. I really think that in the importance of recycling in our house, of using ways of transportation which are more efficient and sustainable in moving ourselves inside the city, or how we design or we build the places we lived in. In every step of the process, I think sustainability should be involved. When you think you are talking with anyone, you should always consider or try to educate the other one to have a consciousness on the impact he is having on the planet. In my courses in the university, I sometimes have students of law, lawyers or engineers, or sometimes even odontologists. So I think that sustainability should involve in every matter of social life. Every one of us could do something to improve the situation, to combat the environmental crisis. Every day we could take a better decision for the planet.
All right, thank you, Professor. I think the key takeaway from this question answer session is to involve sustainability in every step of the way.
Yeah.
So thank you so much for your session. I now request our director to take it over from here.
It was a great session, Francisco. I think our students were also enjoying it equally. So that is why we also see them pouring with a lot of questions. They're too involved in the session itself. Thank you very much. Thank you very much for the session. It was really indeed very, very informative. I mean, you engaged us through all the scales, in fact, right from an individual dwelling to a small campus, to the city level itself, which was very interesting. And rightly, I mean, the students extended the question to a vertical dimension as well, and you answered that quite well as well. So thank you very much. Thank you very much.
Oh, thanks to you.
Pleasure. I would like to pass it on to Ms. Sivashankari to give the session a formal closure. Sivashankari, would you be able to take it over?
Distinguished Chief Guest of the Day, Architect Francisco Godoy, our beloved Chairman, Professor Dr. V.R. Rajendran, respected Director, Professor Vinod Vijay Kumar, Honorable Professors, and my dear students. Indeed, it's a great honor to propose to making this webinar a resounding success. First of all, I'd like to propose a hearty word of thanks to our guest speaker, Mr. Francisco Godoy, for today's seminar. Irrespective of his busy, thank you for your thought-provoking address and making this seminar interesting and meaningful. I would like to express a profound gratitude to our chairman for his presence in this seminar. I'd like to extend my sir for his constant support in making this a successful event. I also extend to a technical team, Professor Dushyant and Professor Elil, in making the web. Finally, I'd like to thank the entire CAD team and the wonderful students who turned up in great numbers. Thank you all.